Solex has been working in the fertilizer industry for more than 20 years now, and actually the first installations of the technology were in fertilizer back in the late 1980s, and that equipment is still working today. The Solex technology is used for pretty much all grades of fertilizer, whether it's urea, ammonium nitrate, NPK, MAP, DAP, and pretty much around the world. We've got installations in India, in Brazil, in the Middle East, in Europe and North America.
One of the things that's so special about the Solex heat exchanger is that it consumes so much less energy than competing equipment on the market.
Probably the main benefit is that it's a very energy efficient or low energy method of cooling fertilizers. All of the others, whether they're fluid bed or rotary drum, use a lot of energy for the fans and for the big drives, whereas in the Solex exchanger it has a very small energy footprint. The big benefit of the Solex exchangers in the fertilizer industry is that there are no air emissions. It doesn't use air as the principal cooling medium, and what comes from that is that you don't need the scrubbers or baghouses to clean up that large airstream. You can't put emissions out into the atmosphere, and so if you have the high emissions that say come with a fluid bed or a rotary cooler, then you've got to put in very expensive scrubbing facilities to keep those emissions down to acceptable levels.
The Solex heat exchanger is sized so that the flow of the product down through the plates is very slow, like in the orders of inches per minute. So the velocity is very low, it's very gentle on the product.
The very low velocities through the equipment mean that you get almost no abrasion, you get no degradation of the product. The long residence time in a fertilizer cooler is certainly a big benefit, because then we get very uniform temperature distribution through the particle. You don't get any reheating when it goes to the warehouse.
One of the things we discovered is the key mechanism behind the caking of fertilizer, and we found how we can control that. So by using our unit in the counterflow method and having the water increase in temperature as it goes up through the unit, it greatly minimizes the chances of caking. Very few other exchangers have that capability on the bulk solid side.